Hello and welcome to the UiPath Computer Vision tutorial. In this tutorial, we'll compare the computer vision activities to the selector-based ones to highlight the benefits brought by this feature. After that, we'll further detail the usage of the computer vision activities by building and running our own workflow. The next feature we're going to examine is the computer vision recording wizard. In the end, we'll take a quick look at some of the best practices in building solid automation workflows that incorporate AI. Let's begin. Computer vision is a new machine learning-based method used to locate screen elements and operate user interfaces. Instead of using the underlying properties of the applications to be automated, computer vision identifies the aspect of various screen elements, as well as the relationship between them. So, this set of activities provides the tools that allow for automating applications for which UiPath cannot generate selectors. Virtual machines such as Citrix, VMware, Remote Desktop Connection, and so on, as well as other unsupported frameworks, Flash, Silverlight, etc. Other uses include cases when the application that we're trying to automate runs locally, but the generated selectors are not reliable. This is where computer vision can help. Now let's compare computer vision activities to selector-based ones to better understand the differences. Here is a workflow that contains a simple click, which you're already familiar with, followed by a computer vision click activity. We'll try to use the two activities to automate an application that runs locally, and then we'll see what happens when the same application is exposed through a virtual environment. Afterwards, we'll see how they work on an image. As you can see, the computer vision click activity is included in a CV screen scope, but we'll explain that later. Now, let's see how this normal click works on our test applications. If we select Indicate on Screen and hover the cursor over the UI elements of this desktop application, we can see that all of them are easily recognized. However, in the virtual environment here, we cannot interact with any individual element on the screen, and the same goes for the web browser. Although some of the elements are identified, the fields in this form aren't, as this is an image. That was the normal behavior of a selector-based activity. Now let's see how computer vision handles the same applications. We'll select Indicate on Screen again, but we'll use the computer vision click this time. The desktop application has the same behavior, so we can move on to the remote environment. With the simple click, no specific element was identified, but if we hover the cursor over the application now, we can see that computer vision enables us to work in this environment without any problem. We can interact with every element: text, input fields, buttons, and checkboxes. And because computer vision works based on how things look, it also works on the image in the web browser. We can detect input fields, text, and also the Submit button. Pretty cool. Alright, now that we've gone through the capabilities of the computer vision activities and the way in which they differ from the normal approach, let's create a blank process to see them in action. We'll name the project Computer Vision Demo. To start off, we need to install the Computer Vision Activity package. In the case of earlier Studio versions, there is an extra step that we need to take before the installation itself. That's because on Studio versions previous to 2019.4, an older version of that dependency is already installed by default, and Computer Vision Pack is installed along with the latest version of the UI Automation dependency. To prevent a dependency conflict, we need to remove the UI Automation dependency first. To do that, open the Projects tab, right-click the UI Automation Activities, and select Remove Dependency. Now we can safely proceed to the regular installation procedure, which applies to Studio 2019.4 as well. Open the Package Manager, search for the Computer Vision Activity package, and click on Install. The computer vision activities have now become available, so we can start building our workflow. The first activity that we'll add to the Designer panel is CV Screen Scope, which is the starting point of every computer vision workflow. This scope activity analyzes the window that we indicate and detects all the elements and the text in it. The screen analysis is then cached and used by every computer vision activity we add in the body of this scope. As the text here is part of an image, we need an OCR engine to extract it for further processing. The engine used in Studio by default is Microsoft OCR, but we can choose a different one out of the available options listed here. Now, we'll indicate the Remote Desktop Session window, which exposes our target application. We've just generated a selector that is used at runtime to capture and analyze the indicated application. Let's take a quick look at the selector. We can double-click the informative screenshot to preview the analysis results and the detected elements, which are highlighted in blue. The CV Screen Scope activity has two properties that we can use to configure the CV server. In the current workflow, we'll use the default UiPath CV server. A very important aspect related to the API key and the URL properties is that their values are synchronized throughout the entire workflow. As a result, if we edit their value in a CV Screen Scope instance, the change is reflected in all the activities of the same type in the workflow. Let's try this out by adding an extra CV Screen Scope activity and editing the value of its API key. When we revisit our initial activity, we can notice that the API key field was updated. Since the UiPath CV server does not require any authentication, we can clear the API key field and leave it blank. Let's resume building our workflow. We'll add a Type Into activity to the Designer panel. We can select the target element either by clicking Indicate on Screen or by pressing the I key. You might have noticed that the screen background has become slightly darker to highlight the window we selected. This is the CV helper. The top section of the helper displays indications related to our selection. The helper also includes multiple actions that facilitate UI element identification. We'll discuss the refresh scope action in detail later. Select After Delay provides a 3-second pause before re-entering the capture mode. Now, this is helpful if we want to click some items without recording our actions, or if a pop-up window is displayed and we have to close it. If we click Show All Elements, we can see a preview of all the recognized elements in our selected area. Report enables us to select any unrecognized element and submit it for review. We'll get to that later. And Help opens the online documentation page. If we click Cancel or hit Escape, this window closes and we return to our workflow without making any selection. If the wizard identifies a valid anchor for our field, the selection is saved and the window closes automatically. If the identified anchor is ambiguous, we can click OK and save the selection nonetheless. As a result, the OK button is useful to force quit the computer vision wizard in this situation. For now, we'll indicate the field where the text should go. When we do that, computer vision automatically selects an anchor and generates the appropriate activities. The CV Type Into activity now contains two blocks. The one on the left contains the anchor text, while the one on the right contains the input field itself. Let's add some text to be typed in the Cache In field. We can easily modify our target by clicking Indicate on Screen again and then choosing something different, say this one. The activity was updated and the anchor was detected automatically. So, the Indicate on Screen option enabled us to change our selection altogether. Now let's try the second option, Edit on Screen. We can either choose the option from this menu or select the activity to be edited and press the E key. The anchor and the target are displayed, and we can edit or remove any one of them. If we want to select a different anchor, for instance, we need to remove the current one first. And the color of the fields has changed. The red color in this field indicates that there is no anchor for the current selection, as mentioned in the helper wizard. And that means the current target cannot be uniquely identified. The yellow color shows us the fields that are similar to our current selection. Those fields are also called false matches or false positives in technical terms. In the helper selection, we're notified that we need to indicate the anchor, but we've seen that it works, even automatically, so let's try something else. We'll pick a different field, such as this one. Since the On Us check field is not unique, an anchor wasn't added automatically, so we'll add one ourselves. The color of the fields is still red. The explanation is once more mentioned in the wizard in the upper left corner of the screen. There are duplicate matches, so we need to choose an anchor, and the wizard shows the duplicates in yellow. If there is no problem, the fields are colored in green. So, to recap this final part, yellow indicates the duplicate matches to the current anchor or target pair, and red is displayed if the current target or anchor target pair is not unique. Now, in this particular case, we could solve the issue by using the image automation feature. To do that, we simply need to draw a rectangle around a unique anchor. And it worked. The selection is colored in green, which means that everything is fine. If we look at the wizard on the left side, we can see that the target and the anchor are okay. We can hit enter now. The activity was updated once again, and our selection is displayed in the Type Into activity. Let's click Edit on Screen again and remove this anchor. Another feature that might be very useful sometimes is the ability of selecting a part of the text or a couple of words. We now want to type into the third text box. Let's try using only the first part of the label as the anchor. We can notice that the anchor we chose for this field is valid. Now, let's move on to an important aspect when it comes to computer vision, refreshing the scope. Let's say that we perform some actions in a certain screen of an application, and then we're led to a different screen. As the screen changed, we need to add a CV refresh activity to our workflow. Why is that? Well, because our first screen analysis is cached in the CV screen scope activity. CV refresh generates a new analysis corresponding to the second screen. To demonstrate this, let's use a click activity to navigate to a different section of our application. First, we select Indicate on Screen and then choose Withdrawal to navigate away from this screen. Let's run the workflow. As you can see, the robot typed the value in the Not On Us check field and then clicked Withdrawal, so the screen changed. Now let's add the CV refresh activity to the Designer panel. If we click the refresh icon here and then select our application, an analysis of the new screen is performed. Here is the screenshot with the highlighted UI elements. Let's use the CV Get Text activity to retrieve some data from this screen. For example, the transaction number. We need to store the result in a variable which we'll call transaction number. Now we can output the number to a message box. So, let's enter the variable we've just created here. Before we run this, let's go back to deposit. So, the workflow consists of writing this value in the Not On Us check field, going to withdrawal, and then retrieving the transaction number. Let's go back to Studio and run the workflow. And here is the transaction number. Now let's picture that we want our extraction to include the transaction word besides the number itself. In that case, our approach should be different. Let's click Indicate on Screen again, but instead of selecting one of the recognized text elements, we'll draw a rectangle around the area that contains the text we want to extract. Let's use this as an anchor. We'll run the workflow, but first let's delete the value in the Not On Us check field. And it worked. This type of text extraction requires the usage of an OCR engine, but the results are not always accurate. As an alternative, we can copy the text directly to the system clipboard to ensure the result is exact. In order to do this, we have to change the value of the Use Clipboard property. The default one is none. We can choose to extract a single word, a row, or the whole text by choosing All. We'll go with Word for now. Going back to the application, let's fill in the first field with a value that will be copied and pasted into the second field. Please note that in order for us to use these options, the target text needs to be selectable, and the clipboard of the virtualized environment must be available to us. Now we've built a CV workflow from scratch. But let's take an even friendlier approach, which will save us quite some time. Let's close this application and open a website containing a form. We'll build a workflow that fills in the form using the Computer Vision recording wizard. Once we installed the Computer Vision activity package, the CV recorder appeared in the design toolbar. The Computer Vision recorder enables us to create workflows much more easily. Or we can use the Ctrl+Alt+A shortcut. FYI, the position of this button might be different from one machine to another. Now let's create a new project to see how the recorder works. When we press the Computer Vision button, after agreeing to the terms and conditions, the recording toolbar is displayed. It contains a settings menu where we can configure the authentication to the CV server. These two fields correspond to the API key and URL properties to be used, but if we're using an on-prem server, no API key is needed. We can also configure the OCR engine to be used. By default, only 2 engines are listed here because we haven't used any other one so far. After we use a certain engine in our workflow, we can also find it on this list. Once we've finished adjusting the settings, we can simply click Record and then indicate the window to be automated. Let's select this remote desktop window. At this point, the window is analyzed by the Computer Vision engine to identify all the UI elements, and OCR detects all the texts and labels. The result of these two combines into a full analysis of the UI and is stored in a newly generated scope activity. We can now start performing the actions that we want to include in our workflow. This works exactly as a regular desktop recording. The analysis of the screenshot taken at the beginning of our recording is used throughout the entire generated workflow, unless we hit the refresh button. However, this list is not included in that screenshot, so we need to take another one. Every time the items displayed on the screen change, a new screenshot needs to be taken. When we built the workflow manually, we used the CV refresh activity. With the recorder, the same role is fulfilled by the refresh button. When we click it, the corresponding activity is generated in the workflow and the new screenshot is analyzed. Moving on, the list item that we're going to select here is Romania, which is not visible at the moment. Instead of scrolling down until we reach it, we can press the R key twice and then hit Enter. Any keys that we press during the recording are turned into send hotkey activities. There are only 3 exceptions: Escape, F2 and F5, which perform specific functions. F2 activates the Select After Delay option, while F5 is the shortcut for refresh. Now that the drop-down list has disappeared, we need to click Refresh again to capture another screenshot. We can notice that the email text box looks different compared to the previous 2. Whenever text elements have an unusual appearance, they might be missed by the Computer Vision detection, as this one is, and we need to use the Type option of the recorder. Otherwise, we can't interact with them, as they're not automatically recognized as text boxes. Select the field, type the input, and then hit Enter. The Click Relative option is useful when we have to interact with the elements that were not recognized completely, such as this link to the terms and conditions. We can use the part of the text that was recognized as a reference and then click on Condition. The screen has changed again, so let's click Refresh. Moving on, the function of the Get option is to extract text from the screen for later use. Let's select the title of the first element and use the title as the anchor. we seem to need a different anchor, so let's use the title of the next section. We can also press Alt plus Left to go back to the main page. Let's save the recording for now and have a look at the resulting workflow. The first activity is CV Type Into, which fills in the first name field. Next, the CV Click activity expands the drop-down list, whose screenshot is captured using the CV Refresh activity. Below, there are 3 Send Hotkey activities, the first 2 to press the R key and the third one to hit Enter and confirm the country selection. After the drop-down menu disappears, another CV Refresh activity updates the screenshot. The following CV Type Into activity fills in the text box that was not recognized because of its unusual appearance. The next recorded step is a click on the Terms and Conditions link, which navigates to a different page. Consequently, there is one more CV Refresh activity, followed by a CV Get Text activity. In the end, the Alt and left arrow key combination returns to the first page. Let's select the Get Text activity to create a variable that stores the retrieved text, which will be displayed in a message box at the end of the execution. Alright, now we're all set, so let's run the process. All the activities in our workflow were smoothly performed, and the execution ended with the message box. Now that we've seen how the computer vision recording wizard works, we can move on to our next topic. Let's go over some features that might turn out to be very useful while debugging a workflow. Let's switch to the Execute tab and have a look at the available options. If we enable Highlight Element and run the workflow in debug mode, we'll notice that every action performed by the robot is synchronously highlighted in red. That means we can follow the process execution step by step. Let's try this out. As you can see, the actions are highlighted in the application itself, and the corresponding activities are also highlighted in Studio. Moving on, a similar role is fulfilled by the CV Highlight activity. Instead of highlighting all the steps, this activity only supports a single one. Let's see how it works. We can use this activity in 2 ways, by clicking Indicate on Screen or by providing a value in the Input Region field. Let's take the first approach. We simply have to click Indicate on Screen and then select an element to be highlighted during execution. Our selection can also consist of an entire area instead of an individual element. Let's redo our choice for this activity to see how that works. When using the CV Highlight activity, we don't necessarily have to run the workflow in debug mode. The target is still highlighted when we execute the workflow normally. The second approach is suitable if the element we want to highlight has already been identified in the workflow, and the related information is stored in a variable. Let's give this a try. We'll use this Type Into activity to create a new variable in the Output Region field. We'll call it First Name field. If we take a look at the Variables panel, we can see that its type is rectangle. It stores the coordinates of the element, which is a text box. Next, we'll set the variable as the Input Region property of the CV Highlight activity. Let's run the workflow to see if this works. And it does. This time, the fields were highlighted in a different color. And that's about it. But before we end the video, here are some of the best practices to use when automating with computer vision activities. Error reporting is a very valuable action that you can perform while using computer vision, because, based on it, we can improve the machine learning model to ensure that every single element is recognized successfully in future versions. To see how errors can be reported, let's select Edit on Screen. On a side note, we could do this in the Indicate mode too without a problem. Now, if you remember, the email and phone fields were not correctly recognized because of their unusual appearance. To report them, we can simply click the report icon in the helper or press the R key, which is the shortcut for this action. To validate the selection, we can hit Enter. Report successfully sent. So, please report any unrecognized element, as that will contribute to improving the accuracy of the computer vision activities. As mentioned earlier, since CV has to work with images, we are using OCR engines to locate text on the screen. Not all OCR engines produce the same results, so you should experiment with all of them and choose the one that returns the best results in your case. Here, for example, this is what Microsoft OCR recognized on our screen. If we switch to another OCR engine, let's say Tesseract, a new analysis will be performed. As you can see, the newly added engine recognizes the terms and conditions text perfectly, as opposed to Microsoft OCR. Another recommendation is to store selectors in variables when using many CV screen scope activities. That enables you to indicate the target window only once and update each activity more easily if needed. To do that, copy the selector, create a new variable, we named it selector here, and paste its value in the default column. Moving on. Some automation workflows might require us to work only on a specific region of an application. If that's the case, we need to isolate that region to prevent false matches issues and accelerate the process altogether. Instead of clicking the entire application, we can click and draw a rectangle in the target area and then release the click. In this specific case, we don't need anything in the lower region here, so we can surround the area that we're interested in and ignore everything else. If we look at the screenshot, we can see that it only includes the selection that we've just made. And that concludes our tutorial for today. We've learned how to install and use the Computer Vision Activity Pack, when the usage of computer vision activities is recommended, how the CV recording wizard works, and what the best practices are. Thank you for watching.